take it to the next level, tying what we talked about yesterday with Internet of Eyes and vision everywhere, and tying that to today, which is about content creation and products that create content. The next level is how, why, and when do we want to create thermal images? Is it just for businesses, or is it for all of us? And we have Travis Merrill from FLIR to give us a keynote about that. Thank you very much, Travis.
Thank you. Thanks, Evan. Good morning, everyone. I'm Travis Merrill from FLIR. We are the world leader in thermal imaging technology. We've been around for about 40 years. And today I'm going to take you on a tour of three things. The first one is looking at the recent revolution that's occurred in thermal imaging technology. Secondly, it's really to take a look at what I like to call superpowers of thermal imaging technology, very unique properties, and how those might be leveraged is the last thing I'd like everyone in here to think about. Many of you probably recognize this image. It's a bit of an iconic image, and for those of you who do not, this was from that harrowing day in April of 2013 in the aftermath of the Boston Marathon bombing. The reason I'm showing it is really twofold. One, this is how a lot of people think of thermal imaging today. This is really one of the traditional use cases, military, law enforcement, somewhat scary, right? But secondly, if we step back and just think about this superpower-like technology, the ability for the mass state police to look into a covered boat, see a suspect in that boat from the air in almost total darkness, it really encapsulates a lot of the value proposition of thermal, and what are the implications for that for the broader society if we can deliver that to the world. We like to position ourselves at FLIR as the world's sixth sense, and the sixth sense that we're talking about obviously is that thermal world that's all around us. Everything in the world emits a thermal signature, has thermal energy. Our technology allows us to see that, to visualize it. There's a piece of temperature data on every single pixel in the image. Imagery that can really see the most subtle temperature differences that exist. Imagery that can allow us to spot a defect or a malfunction or a leak before it becomes a major catastrophe. Imagery that can distinguish between the living and the non-living, sometimes with potentially life-saving implications. And then imagery that can just fill in some of the missing puzzle pieces in daily life. And then finally, imagery that sometimes is just stunningly beautiful. The industry and the technology has come a long way over the past 50 years from its origins in the industry. And when it first came about, these things were very large, hard to set up, very expensive. And it's changed dramatically over that time frame. We've gone from degrees in sensitivity to hundreds of degrees in sensitivity. We've gone from 20 pounds to fractions of a pound. And we've actually seen this story before in the imaging world. In the early 80s, obviously, visible imaging was fairly commonplace. But based on CCD technology, it was very expensive and very large. And then the CMOS sensor came along, and the game changed. All of a sudden, there was a digital imaging revolution taking place by the mid-90s. Who in 1982 would have imagined that a CMOS sensor would be in every single automobile, every single cell phone, every single computer, and in many cases, multiple sensors in the future, and that quickly, actually. There will be about 4 billion CMOS sensors sold this year, if you just think about that for a second in terms of the scale. So what does this mean for thermal imaging? Well, the CMOS implication for us is thermal actually can play a strong complement to the visible imaging world. And it also brings some interesting differentiators from the visible world. And again, I like to think of these as superpowers, and I'm going to just show you a demo of each one. The first one is the ability to see in total darkness. There needs to be no light to operate. You can see in shadows, no illumination necessary. Secondly, you can see through obscurance like smoke, fog, haze. You can imagine what a valuable tool this is for firefighters, but a number of other professions historically as well. You can measure temperature very minutely, and you can see potentially a catastrophe before it occurs. You can get alarms based on a certain threshold that you set for the temperature measurement. And thermal imaging is actually very good at long-range imaging as well because it's not as affected by atmospheric turbulence, dust, haze. So it's actually one of the preferred imaging technologies for airborne perspective. It has the ability, obviously, to accurately detect people and animals from inanimate objects, and it does that very, very well, much better than visible. This is interesting in security applications, but it also has a lot of implications for in-home cameras as well. And then this one's kind of surprising to a lot of people. It has the ability to see gas. With some spectral tuning of the camera, you could see CO2, you can see methane. Huge implications for our environment. Many of you probably are familiar with the Aliso Canyon methane leak that occurred recently in Southern California. That leak was really brought into the public consciousness through thermal imaging, viewing that, and the media picking that up and showing it, and people were outraged, and now there's been a whole wave of regulations around that. You can see that with thermal. So back to the past for a second. What has occurred to really catalyze this for the broader mass market over the past couple of years? Well, first of all, the usability problem has gotten essentially solved. These things are point and shoot. You can carry them in your pocket now. The image quality has also gotten considerably better, not just from improving the sensor, but also through a lot of image enhancement algorithms. This is one example that we call MSX, something that we have patented, where we take the details of a visible image and we overlay that on the thermal image to provide much better context. And then, of course, like all technologies, cost has fallen significantly. A camera today that's less than $1,000, well under $1,000, has much better performance, much better image quality than a camera 10 years ago that may have cost $10,000. And this year, in this industry, we will sell as many sensors per day as we did in all of 1990. So it's really rapidly changing and growing fast. This has been driven by something that we innovated a couple of years ago and announced a couple of years ago called Lepton. It was the first thermal micro camera core, roughly the size of a pencil eraser. It dramatically reduced the size, weight, power, and cost, and is really opening up a lot of new markets. We've incorporated this in almost 15 FLIR branded products, but we've also been selling it to a lot of other manufacturers around the world who are incorporating it in their own products. Our first product to really bring this to bear was the FLIR One. And this is ostensibly the first consumer product, thermal imaging product. It's an accessory for your smartphone, gives you thermal imaging right from your smartphone. And we launched this 2 years ago, sold in Apple stores, $250, quite accessible. And we've been really interested to see what has come out in terms of use cases from consumers, because we knew that there would be a lot of innovation out there just in the hands of consumers and in the creative community. Everything from DIY energy audits in the home to seeing which bread is freshest at the bakery, to seeing exactly where your pet may have relieved itself on your living room carpet. These are all things that real use cases that we've seen, and they're all sort of niche-y, and some are a little bit quirky. But we're really still in the early stages of what that's going to bring in the mass market. One way that we're trying to encourage that is we have an active developer and maker program, and we hold events every few months with challenges around this technology and how to leverage it, both the core technology as well as the FLIR One. We've had about 30 apps released on iOS as well as Google Play for the FLIR One now, third-party apps. So when we think about the future and how this is going to be leveraged in those superpowers, one spectrum is these established use cases. These have been around for 10, 20 years in many cases, yet they're not very penetrated because we were talking about cameras just a few years ago that were $5,000 and $10,000 a piece. All of a sudden, it's accessible to many of these markets in a way it's never been accessible before. One example of that is the first mobile phone to ever integrate thermal imaging. It's a ruggedized mobile phone targeted at commercial and industrial type users. These are people who understand the value proposition of thermal, who probably always wanted a thermal camera but couldn't afford it. This will be launching in just the next month or so. And then there are all these emerging use cases, things that are just starting to come to bear. Some have started to come to fruition. And I'll show you two really quickly. One is an aerial view, a collaboration we've had with DJI called the ZenMuse XT that gives you thermal imaging from your DJI drone. And this really will allow perspectives, positions, and angles with thermal imaging that really couldn't have been imagined a few years ago. Large implications for real estate agents, building inspectors, firefighters. And then finally, in the context of the smart home, thermal does some things really well, and in fact better than visible in terms of its accuracy as well as its potential for greater privacy for the people in the home. And it's something that's constantly being investigated for incorporation there. And so, final thought, I'd like to just invite everyone here and challenge everyone here to think about this technology as another sensor. It's another layer of data. It's a missing puzzle piece. And think about how it can be incorporated into your work and into your life. Thank you.
Thank you very much.